On the northwest coast of Borneo lies the Seria oil field with its inshore wells. A survey indicated that the existing structures extended beyond the coast and out into the sea. It was decided to start drilling at the point marked by the arrow, which is some 5,000 feet from the coast, or that's nearly a mile out to sea. At this point, the sea is on the average 27 feet deep. The plan was to erect a drilling platform and derrick. One problem was the transport of personnel and equipment from the shore to the platform during drilling operation. Because of prevailing bad weather and rough seas, movement by launch would be difficult and on occasion impossible. So it was decided to erect an overhead cableway from the shore to the drilling platform. The cables will be carried by 6 cable towers, 5 in the sea and 1 on shore. On the seaward side, slightly beyond and to the left of the derrick in this sketch, a further tower was to be put down as a terminal anchorage for the cables. The assembly work for the platforms and equipment was done inshore, 7 miles from the site in the AEO-Light river. The units were to be towed down the river and out to sea on barges which would float them into their positions. This film record starts from the point where the foundation structure for the main platform had already been assembled in the river and was ready to be floated out to sea. Here in the AEO-Light river, all the main steel erection work was carried out. This is the jacket structure in its almost complete state. Through the jacket tubes, the bearing piles will be driven when the structure is floated out. The piles at its 4 corners will be used to pin it to the seabed immediately after placing. Everyone was briefed, each in his particular job, and if the weather was favorable, the towing and launching would start at dawn the next day. 7 miles away, back on the coast at Seria, final preparations were being made for the job. Information about sea and weather conditions had been gathered in an attempt to predict the best weather for the job. On top of one of the derricks, a wind anemometer had been fixed so that wind forces could be charted. Observations were made of the sea and swell. A tide gauge recorded the rise and fall of the tide. At first light next day, the structure slowly began its journey out of the river to sea, a 7-mile tow. It was suspended between 2 barges and weighed 90 tons. A small fleet of tugs, light craft and divers' launches went ahead out to sea to await the arrival of the structure. Soon she was clear of the AEO-Light bar and course was set to the sea location. The whole convoy went at a speed of about 4 knots. The jacket was bolted to the sides of the superstructure on the barges. One of the lowering tackles can be seen here in the center of the structure. The convoy reached its position and launches brought in prepared mooring wires to secure it. It had to be positioned exactly at 90 degrees to the shore cableway station because of the cable which was to be erected later. This was done by taking bearings from 2 pairs of beacons erected on the shore. And here surveyors were checking the position. Contact between the survey parties was maintained by radio telephone. These messages were passed on to the mooring crew. As soon as the jacket was secured in position, the tie bolts were taken out and it was left suspended only by the 4 lowering tackles. These draft marks painted on the sides showed that the whole structure went down squarely. The tackle was operated by hand winches and so lowered very slowly into the sea. When everyone was satisfied that all was under control, the winches were put into a higher gear and the structure lowered onto the sea bed. Then the steel erectors went aloft to remove the guide brackets which had kept the jacket between the 2 barges. Meanwhile, back in the AEO-Light river, the intermediate cable towers were being assembled. They were erected and slung between 2 barges which were held equidistant by Bailey bridging. From here they were to be taken out to sea and lowered into position. Unlike the jackets for the main platform, these intermediate towers were comparatively light, and so it was possible to tow them out to sea 2 at a time. This is the bridle and lowering tackle. Here a prefabricated section is being lifted into position and bolted in place. As soon as tides and weather were favorable, they were to be towed out to sea in pairs. There were 6 of these to be put down. The first of these intermediate towers was being lined up into position at sea. Securing bolts were taken out and the structure lowered. Then it touched bottom. The clamps were removed. The barges pushed clear of the structure. This left the intermediate tower in position. Then a floating crane came alongside and lifted the piles into position. The piles were driven in by means of a steam hammer. The tower was secured with 4 piles, one at each corner, and these were driven firmly into the seabed in welded sections to a depth of about 120 feet. Piling had to be done as quickly as possible, as once the tower was in position, the swell would very quickly create a scarring effect around its base and throw it out of alignment. Back on the main structure, piling had been completed and a temporary decking put on top. Then the second tier was lifted onto the platform. This tier would form the floor for the drilling machinery. These sections were prefabricated on shore and carried out to sea on barges. Under the feet of this section, steel packing had been inserted so that the top of the platform would be level. Back on one of the intermediate towers, the erection of the trestle which would carry the cable was taking place. This was a tricky job because the steel work of the trestle was rather high for the only crane available. The steel erectors hand up the bolts for securing the shoes. Temporary guy wires were secured to hold the assembly in position until the permanent guy wires could be rigged. This hinge at the bottom allows the trestles to swing freely when the overhead cable car is in transit. The height of these towers is 73 feet above sea level and they're spaced 840 feet apart. With one intermediate tower completed, the floating crane moved on to the next. Soon 2 towers were completed whilst tugs were towing the next 2 into position, and so on until all 5 towers were finished. There was considerable swell on this particular day, which made it difficult to get these towers accurately lined up. The inshore tower was positioned in shallow water near the beach. This was done with the aid of a crane and shallow draft vessels. A heavy storm was brewing up at sea and work had to carry on against time in order to get this delicate operation complete before the storm broke. The sea and the swell were rapidly on the increase. The crane picked up the tower and swung it into line with the seaward towers. This swell caused a rapid scarring effect around the base of the tower, and before the steel piles could be driven, the tower had developed a severe lisp and had to be righted by means of cables from the shore. At the same time, construction work was going ahead on the foundations of the shore station. Here the land is only a few feet above sea level, and water creeping in from the sea presented a major hazard to the work. It had to be pumped out continuously whilst the work was going on. This excavation had to be filled with concrete to make a firm anchorage for the shoreward end of the overhead cables. Concrete mixing was done on the spot and poured straight into the excavation. Well over 100 tons was used. A similar anchorage was made on the seaward tower by means of prefabricated concrete blocks. Near the main platform, the seaward tower was being lowered into position. This tower would form the seaward anchorage for the overhead cableway and enable the cable car to end its journey at the main drilling platform. It was lowered into position. Here again, the swell made the positioning a tricky job. When it was within a few feet of the sea bed, its position was finally checked by means of steel tape. This was to ensure that when the double trestle was mounted on the top, it would be dead in line with the rest of the cable railway towers. To prevent them from bumping it out of position, the barges were quickly towed away and back to base for the last time. By now, the top of the main platform was ready for its derrick and drilling equipment, and the 5 cableway towers were completed. This A-frame, mounted on a barge, was used to lift the double trestle into its position, spanning the main platform and the seaward tower. The seaward anchorage for the cable railway will terminate at the apex of this trestle. As soon as the trestle was lifted clear, the towing barge went back to base to load up with drilling equipment. The stress of the cables will be taken by the 4 legs of this frame. On the 2 inshore legs, the stress will be taken by raker piles on the main platform. On the seaward platform, over 100 tons of concrete ballast will be added to counteract the pull of the cables. The fitting of this double trestle was done in 1 day, and during the same day the drilling equipment was lifted into position on the main platform. The weather was good and an enormous amount of work was done in a relatively short time. Some pieces of the drilling equipment were heavy, weighing as much as 22 tons. A few days later, on the shore, twin 6-inch pipelines, a mile long, were being hauled into place. Nearly 250 drums were used to float them on their 42-mile sea journey from Lutong, where they were built on existing tracks and ramps. These lines will carry fresh water and drilling mud from the shore to the drilling site. Soon the cable wires were being pulled up onto the cable towers. Track cables were carried in shoes, which were hoisted into position and secured to the apex of each intermediate trestle. These cables are just over 5 inches in circumference, and each weighs 13 tons. When all the cable shoes were in position, the snack cable railway wires were tensioned from the shore. By now, the drilling derrick had been erected. Tensioning was done with the aid of bulldozers. These track cables have to be kept at a tension of 40 tons, and a tension meter had been installed to constantly check this. And so all was ready for the first trial run. Here only the cable traction car was used. Later the passenger car was to be hung from the underside. Once the tests had been successfully completed, the passenger car was fitted and the cableway was open and running. The whole project of placing the platform and laying and erecting this marine cableway and the oil derrick nearly a mile offshore was done in a period of some 5 months.